the velocity vector versus the directional vector. How these two vectors differ is a little bit confusing, so let's first define both of them. The velocity vector gives me two things. It gives me the direction an object travels, and it also gives me the speed the object is traveling. A directional vector gives me the direction the object travels, and that's it. I do not know the speed. So if I let v equal to the velocity vector, and I say it's 3i plus 2j in feet per second, the directional vector I'll let equal to 2i minus 3j. Now notice the difference here. This part of the vector tells me that I'm going 3 units to the right, 2 units up. So I'm traveling sort of in this direction. And it also tells me my speed. My speed is done in feet per second. Whereas over here, this tells me I'm going 2 units to the right, 3 units down, somewhat in this direction, and that's it. It doesn't let me know how fast I'm going. Let's just see this pictorially. Now, vector v was the velocity vector vi plus 2j in feet per second. Vector d was the directional vector 2i minus 3j. That's it. That's the direction I am traveling. And the first thing I'm going to do is I'm going to write vector v in its component format. All I do is I write it as a matrix. I'll do the same with d. Now to graph v, that means that my x component is 3, so I go 3 units to the right. My y component is 2, so I go 2 units up. And this is my vector v. Actually, this is just the direction vector v is going. Now vector d, do the same thing. I go 2 units to the right, 3 units down, and here's the direction vector d is traveling. Now how vector v differs from vector d is very, very simple. Vector v has a speed. Its speed is its length, also known as its magnitude. Remember, we compute magnitude by doing the Pythagorean theorem. X squared plus y squared equals the hypotenuse squared. So moving on, vector v is equal to the square root of 9 plus 4, which is equal to radical 13. Or I could say that vector v is traveling radical 13 feet per second. Or in 3 significant figures, I'm going 3.61 feet per second. So to recap all of this, vector v lets me know I am traveling somewhere in this direction. There is no other information given except that I am going in this direction. Whereas vector v, I am going in this direction right here, but I am also traveling at a certain speed, 3 feet per second. So I know exactly where I'll be in 2 seconds. In 2 seconds, I would have traveled twice this distance, 7.22 feet. Whereas vector v, vector d right here, in 2 seconds, I don't know where I'll be. All I know is that I am traveling in this direction. Okay, let's try to make a little bit more sense of this. Here we have a problem. If an object is traveling in the direction of -3,4 at a speed of 10 miles per hour, find the object's velocity vector. Now, first of all, right here, it says the direction of my object is -3,4. That means that my object is traveling 3 towards the left, 1, 2, 3, and then 4 units up, 1, 2, 3, 4. So that means that my object is traveling in this direction. Now, we know that the speed of the vector or the object is 10 miles per hour. So what we want to find is we want to find a vector that travels in the same direction as this vector, with one subtle difference. This vector has a speed. Therefore, what we want to know is, we want to have this vector with the distance of 10. Why 10? Because we are traveling 10 miles per hour. Now notice that my directional vector and my velocity vector are parallel. So I will be using the parallel equation to find my directional vector. Now, if I remember correctly, if vector D is parallel to vector V, then there exists some number such that vector D will equal to vector V. Now first thing I'm going to do is I'm going to write everything in component form. So first of all, what is vector D in component form? Going back to my problem, vector D in component form is right here, -3, 4. So I'm going to place that right here, -3, 4. I don't know what my vector V is, so I'm just going to call that my variables, x, y, because I don't know. Now, what do I know about these two equations? Going back over here, I know that the magnitude of the vector is right here, 10 miles per hour. So if these two vectors are equal, what I want to get is two equal vectors, then that means that these two vectors have to have the same magnitude. Or if this magnitude is 10 miles per hour, then that means that this vector must have a magnitude of 10 also. So remember, magnitude is written in absolute value. Giving myself a little bit more room, that means that k is equal to the square root of -3 squared plus 4 squared, which we want to be 10 miles per hour. I'm sorry, it is not k equals 2. As you notice, it's k times, so k times that magnitude. Simplifying, k times 9 plus 16 equals to 10. Or k times 25 equals to 10. Simplifying some more, 5k equals 10. Using the multiplication property of equality, and I'm not really dividing by 5, I'm multiplying by 1/5. That gives me k equals to 2. Now, coming back up here, k equals to 2. So if I substitute in this equation 2 times my directional vector, which is -3, 4, will equal to my velocity vector, which is x, y. Or, distributing my 2 across here and here, that tells me that -6, 8 is equal to my velocity vector, x, y. So here I have the velocity vector of my object. This concludes this portion. Please go to the next video.